Hey, hi everyone. I'm Chip. I cannot believe that I'm gonna be in Oakland one day. It's like so far. It's incredible though. Before I went here, a lot of my friends told me that like apparently New Zealand is famous for like bunkers in case of apocalypse. Wait, you don't have one? Like who here has one bunker? Nobody? Oh, okay. We need to get to it then. Okay, so today I'm going to talk about Composable data systems and unified DataFrame API. So this is like touched mostly on open source. So that's something you can just like try out anytime. Does anyone recognize this saying, this code from a paper called AlexNet? Who here knows AlexNet? Okay, so this is a very cool paper. So AI was going through like a long winter, and this paper was created with like the revival of deep learning in 2012. So the idea is they just made the model bigger, and it got really good performance. So back then, the paper has this one line, like a pretty throwaway comment that nobody paid attention to. It's like, all our experiments show that if you just put more compute and more data, you will get better results. And back then, it kind of like offended me, because I feel like as a human, I really appreciate like intelligent design. But here it's just saying that you're just brute forcing it, just put more data and compute. So the second author of this paper, Ilya Sutskever, he went on to co-found OpenAI. And it's pretty much he's been living out his hypothesis of like scaling up compute and data. So when I read this paper, I was like a freshman in college, and it's pretty much decided my career trajectory. So after that, my first job was at NVIDIA, because I thought like it could be really cool to learn about compute. And then after that, I worked with several AI data company, because data is important. So when I talk about data and AI, people keep asking me, so how has AI changed the data landscape? So a lot. I think I see a lot of things that have changed in recent years, and I do think that a lot of things will continue to change in the next few years, or maybe like forever. But here's the three things that I thought was like really cool. So first, we are going more from like structured data to unstructured data. So before, a lot of machine learning use cases are tabular data, like with recommended system for detections, and a lot of work was like working with like trying to find like good features. But now, like with on the model like ChatGPT, Claude, Midjourney, you're working with a lot more unstructured data. So I think like it's also I felt like when I was started with data, people kept telling me about the lie between like unstructured versus structured data, like ETL or ELT. But I do think that the lie between structured and unstructured data is getting more blurred, because right now there are ways for us like to store data in an unstructured manner, but then query this unstructured data using like more structured languages like SQL. So this shift also leads to another shift, like from feature engineering to context constructions. So previously, say if you want to make do fraud detections. So a lot of work are involved in like feature engineering, trying to like come up with new features that can help you make good predictions. However, with the new paradigm of like LLM, large language models, we have a query, and we try to supplement this query with like second documents or like images to help the model generate better responses. So this process is called like context constructions. Who here is familiar with RAG? Whoa, that is like, I feel like it's like really good. So like RAG, so you probably know, so the idea is like given a query, you try to retrieve relevant context for that query. So we have been a lot of research to show that models, if you ask a model using, for niche information, the model is more likely to hallucinate. But if you provide with the context, it would be a lot more accurate. So RAG is really good with that. So we see more like, so context and feature engineering serve the same purpose, and I should provide necessary context for the model to make predictions. Another thing is just like the shift from CPU to GPU. So before, when I started in data, everyone told me that, we have to do data processing on CPUs because data require a lot of memory, and GPUs just don't have enough memory for that. So are you familiar with all like the difference between like CPU and GPU? Yeah, I thought it's like the chip design is very cool. I feel like especially with the NVIDIA going through the roof, everyone has been trying to understand like, what made NVIDIA so successful. So like at a high level, CPUs have like a few number of cores, but with a lot of like very powerful cores and with a lot of memory. Whereas GPUs have like thousands of like small cores, less powerful, but it makes CPUs really easy, really efficient for parallel processing. And data processing is very naturally parallelizable. So if you want to process like a billion rows of data, you can just farm it out to like thousands of cores and make things a lot faster. So I bring up this quote, but I feel like it's natural that Jensen Huang probably want to move everything onto GPUs. But I do think there's some truth to it. So before, people were like, you don't have any GPUs left for data processing because for many years we were going like because of Bitcoin and like on early model training. For a long time we had a GPU shortage. But nowadays I don't think like that shortage is like, I feel like we are at the phase when we have a lot of GPUs. So people were like, we only have GPUs for training and inference. Nobody has GPUs for data processing. But now we can see that people usually use the newer generations of GPUs for training, like the weaker generations of GPUs for inference. And then we have a lot of older generations of like GPUs, like T10 and stuff for like data processing. So here we have done several benchmarks to show that by moving data processing from CPU onto GPUs, you can not only speed up the process, but also like save a lot of money. So here, for example, you can see in our benchmark, compare Spark, which is on CPU, and Theseus, which is on GPU. So you can see like for like 10 terabyte and 30 terabyte, the Theseus is like a lot cheaper and faster. Like sometimes you can save the cost by like 100, like 2 orders of magnitude. We did Theseus benchmark for 100 terabyte, but not Spark on 100 terabyte because it's really hard to scale Spark to handle that large query. Who here has been able to scale Spark to 100 terabyte? Good. I feel like I was always afraid that one day someone would raise their hand. It's like, it's super easy. Yeah, so we are not the only people doing this. So we do see that because of this, like, so data system have be complicated, but with AI, like, it's become even more complicated, and we have like diverse needs of data now lead to like diverse desired data systems. So we see like several like divergence. So first, the classic one is like local versus distributed. So I guess that everyone here is from data engineering background, right? Anyone here from data scientists or, okay, 3 timid hands. Like I'm surrounded by enemies. So we see that like, so I'm from a machine learning like data science background, and people, I still always see this a little bit of like tensions between data scientists and data science, data engineering, because data scientists work a lot with like notebook, local, like they maybe experiment with like pandas, and they come up with like really cool features, and they have to like send to data engineers to like convert those into like things for like distributed like SQL or like whatever backend people run. And there's a lot of back and forth, and it causes a lot of error. We see something like so sometimes we see like it takes like months for people to deploy a new feature because the process is like a lot of like, sometimes things work quite well like on my machines, and then it doesn't work in productions, and people don't quite know why, and like, everyone blames each other. So another divergence is like Adi gave a great talk about is like batch versus streaming. So we see a lot of things in batch, but also like we see more and more people adopting streaming. And a lot of things that are easy in batch, but like really difficult in streaming. So for example, like computing median. Like if you know all the data in advance, right? If you want to find the median, you just look at the value in the middle. But like let's say like how do we find the median of like incoming stream of data? Where you can't just store all the data to know exactly. So it's just like, how do you keep on a running value of median? I feel like that could be a fun interview questions. So the last one is we talk about a little bit is like CPU versus GPU. And we are not the only people doing GPU native data processing. So there are other tools like Dask. And NVIDIA also has a team called Rapids AI, whose whole goal is to like move more and more, and they should create more tooling around GPU processing. So first we have like QDF. Does anyone here know QDF? Okay, a few people. So these are pretty cool. So recently at the Brick Summit, they also announced a partnership with NVIDIA to like bring more like Spark onto GPU. So with giving all of this divergence in like data systems, it can make it quite hard to build a custom data system to your need because you have a lot of components need to work together. So when we look at data system, we usually separate them into 3 different layers. So at the bottom, it's like how data is stored, like where do you keep your data. So first we have like data bricks on a Snowflake. And then on the top is just like the execution engine. It's like how do you execute so different queries, computations you want on top of the data. So first we have like BigQuery or like Snowflake SQL. And then on top of that, we have like user interface. It's like how you write the queries. So typically people are like divided between like SQL and DataFrame API, like Python. So who here thinks that SQL is a better interface for data engineering? Okay. Are you the same person who say you're from data science? That is very rare. So who here thinks that DataFrame API is better for data engineering? Okay, so the rest of people was just like, I'm not gonna out myself. Okay, so yeah, thanks a lot of the, even within SQL or DataFrame APIs, there's a lot of differences. Like every like SQL have like 1,000 different dialects, so it's DataFrame API. So traditionally, there's a coupling between execution engines and the user interface. So what that means is that, let's say, if you want to run the code in Snowflake, you wouldn't have to write the code in like Snowflake SQL. If you want to run things in like DuckDB, you have to write the queries in DuckDB API. So that makes okay if you just want to stick with like one tool. But as we mentioned, our data system is actually quite complex, and especially if you have a big team, like with everyone has their own preference, everyone like wants to use their own tools, it can be quite challenging to work together. So here's an example of like just how like different. So I use DataFrame API here, but we have the same problem with SQL. It's like you can see like the same kind of like computations. You can have very different queries, like just from 3 different tools. And imagine that you have like a lot of queries. It can be quite a pain to like translations. And there's no okay, I'm never able to say the word interoperability. Okay, I hope you get what I mean. So it's quite hard for teams to collaborate with each other. So that just summarize, here's a few challenges with like this ecosystem that is so fragmented. First, it's like there's a lot of effort to build a custom data system because now you have to like look at different components and try to get them to work together. So we see companies like investing a lot in the engineering team. If you're lucky, there are a lot of companies I see that don't quite invest enough in data system or data engineering team, and it causes a lot of pain, not just for data engineers, but like all the user downstream. A lot of like code rewriting and translations. For example, like you do local experimentations and expect someone to like rewrite the code to like deploy the code for you. Also like runtime inconsistency. So we keep hearing things like, oh, this works perfectly well in experiments on my local machine, but then it doesn't work in productions. So there's a case study by Pinterest. I saw that like when they compute values in productions and then they store the value in batch and recompute the value, they found that about something like 90% of the values are not the same. So like the amount of inconsistency is like insane, especially if you do like streaming versus batch. And the last thing is a little bit more like less frequently occur but can be quite important is a vendor login. So say if you're on Snowflake or Databricks, if you want to like switch to another vendor, you have to like rewrite or like change all the code for that, and it can be quite painful. So that's why also like a lot of like maybe I wouldn't say that, but like maybe a lot of incumbents don't quite want you to like have tools to make it's easy for you to get off their platform. So this is a paper about like a few years ago at VLDB. So from like someone on our team together with like Meta and Databricks and Sundeck. So this paper is about a composable data systems. So I felt like I don't really want to say the name because I feel like no paper should ever have the name manifesto on it. But it works. So I think it's very cool. So the idea is like, what can we do like as an ecosystem? What can we do to make it really easy to make our data system really modular and plug and play so that like anyone can just like build a system that we need. And if we need to change our tool, we can just do that without causing an arm and a leg. So I think like there have been increasingly more standardizations. For example, anyone here knows about Iceberg? So Ibis is very cool. It does have like standardized storage layer. And Anthony, we also see like Apache Arrow. So who here knows Apache Arrow? Yeah, so Apache Arrow is like a standardized in-memory format, which makes it a lot easier to move data between different engines. And today I want to focus more on Ibis, which is like also an open source project, and also a newer project. So the idea is to unify the user interface so that you can have one interface to work with like multiple execution engines. So the core fundamental ideas about Ibis is that Ibis is decouple the interface and execution engines. So what does that mean is that like now you can write code independently of like what engine you run underneath the hood. So let's say you write a query in Ibis and you say, I want to run this query in Snowflake. It will compile into Snowflake SQL. If you want to run it in Databricks, then it will compile into Spark SQL. So whenever we give this talk, people would always send us this SKCD. And I think it's true. Like it's really hard to create something standard and like expect people to just adopt it. So we did spend a lot of time thinking about like what could be the requirement for people to like adopt like a unified API. So we think there's like that 3 key requirements. First, it has to be extensible to a wide range of like backends, not just today backends, but the future backends, because we don't know what the future competitors like cool execution engines we will have. Second, it has to like achieve native performance. So what that means is that like if you write code in Ibis and compile into Snowflake SQL, it will run just as fast as if you were writing it in Snowflake SQL directly. And third, it has to be like give consistent results across framework. So say you write a query, it compiles into Snowflake, and you compile again into DuckDB. The results have to be like consistent. So I think that for the first part about like extensible, so I think that Ibis has proven to be quite extensible because we were able to extend it not just into a batch API, but also streaming API. So we support also Rising Way and Flink. And I think that it's quite a challenge to be able to like extend the batch API towards streaming, because streaming has own very interesting, very useful syntax like windowing functionality, but it's really hard to do in batch. So this is how it works underneath the hood. So we write APIs that look like this. It will compile into some intermediate representations, which is SQL equivalent, like relational expressions, and then it will compile into the underlying backend, whichever you specify. So this is not interactive, so you can't click through it. But here's a line that tell you like which engine you want to run through. For example, if you want to run into DuckDB, you select connect to DuckDB, and if you want to switch to Snowflake, you just change to like Snowflake. Oops. So I think like one of the coolest thing about Ibis APIs that people told me is a magic underscore. So the idea is that you can use the underscore to represent the output from the last expressions. So they can chain different expressions together to create something quite complex. So here's how it would change a pretty complex query, and that is something you can't really do in SQL. Like I think it could be this query, if you want to translate it into SQL, it would be like really, really complex. So I think there's a big debate on like SQL or on DataFrame. So I know that some people on our team don't realize SQL. I think like one of our engineers went to an event and gave a talk about like why SQL sucks. But I think SQL is very cool, and we do respect people's needs to use SQL. So we do support like yes, you can also write SQL directly. By the way, anyone here knows about like on the text to SQL models like demo? Has anyone tried or like try to build? So like when ChatGPT came out, for some period, like for a few months, like every week I would got like 2 or 3 people reaching out, like, hey, want to try my new text to SQL models? And I'm saying like, wow, people would just do anything to avoid writing SQL. So I think that it could be, so yes, you can write SQL in Ibis as well. So even though I say this like, it's very extensible, it's a community project, it's open source, it's not easy maintaining something like Ibis. And the reason is that we need to like keep, so we need to like stay up to date. We need to understand all the backends really well, and we need to stay up to date with this backends like improvement, right? So let's say like one of the backends add a new functionality, we would need to try to support it. So that's a reason why we decided to make it open source so that we can collaborate with people in the community. So we also work quite closely with a lot of like the backend developers to make sure that our Ibis is like have a pretty good coverage. Like for example, like for our popular backend, we aim for like not 100%, but like pretty close to it. And it's not always like a one-to-one mapping because let's say there are things you can do in Snowflake you cannot do in DuckDB and vice versa. So there's not always a one-to-one mapping. So there's like something that we also provide what we call like user-defined functions so that you can also like define their own queries, functions that Ibis does not support natively. So here's some of our benchmark to make sure that Ibis runs quite fast as the native engines. We also have a lot of tests to ensure consistency. So I think that's something we get for free if you move to Ibis, is that the results will be consistent, like local or remote, or like different teams working together. So here's a little bit more how it works underneath the hood. So with our Ibis, let's say you have a local, let's say pandas. Who here still uses pandas? I think that pandas is very cool. I like West. So the person who created pandas is the same person who created Ibis. So I think like pandas is very cool, but I do think just like pandas has certain limitations on how it handles memory. So it's quite tricky. So we can see more about this. So let's say you use local and you want to connect to like a remote engine. So first, like you want to like let's say you want to like do some query on top of the table called ratings. So without Ibis, it would have to like slope up the entire table locally. So regardless of like maybe this table has like 1,000 of columns, right? You don't need access to 1,000 of columns but if you want to do some computation, you have to like slope up the entire table, which can like consume all the memories. So that's why pandas have a lot of like our memory issue. So like with Ibis, so we do it a bit differently. So let's say you connect to a remote table. We actually don't get the entire table content, we really get the table schema. So we get the column names and column types, and then we only define the queries on top of the schema. And only when we execute this query, that we get the data relevant to the queries. So that helps us avoid reading the entire table and can help you manage memory a lot more efficiently. And one cool things about this is that if you have a metadata store, you can just connect to the metadata store without connecting to the actual data. So that allows you like if you move the data between different storage, you only need to keep the metadata consistent. You don't have to rewrite anything. And if you don't have a metadata store, you can also define the metadata in Ibis directly. So I do think that's like, it makes sense. I do believe that standardization makes sense because it makes everyone's lives easier, but it's not easy because like someone needs to take the initiative to like build the unifications and standardizations. However, I do think that like standardization is inevitable. So first of all, Apache Arrow starting out as like a pretty ambitious project, but you can see on the left, these are all the data engines that are now using Apache Arrow underneath the hood. So I could say that Apache Arrow has been pretty much accepted as an industry standard. Also, fun fact, the same person like Wes also created Apache Arrow. So he's a super cool and the nicest person ever. Maybe next time Peter should try to get him here. So yeah, so here are some of the benefits, just to summarize, benefit of like something like Ibis. You can experiment locally and deploy remotely, like without rewriting the code. You can unify batch and streaming for free. You can collaborate among different teams who have different backend preferences. So that is one of the big adoption. Also, there are two types of like organizations that we've seen a lot of adoption with Ibis. Ones are like bigger companies when they have a very large data engineering team and have like multiple teams, multiple engineers working with different backends. The second are the data consulting firms or data platform teams when they have a lot of customers who come in with their own backends. So we see like people using Ibis to make it easier to work with their customers. And another use case I find interesting is like using Ibis as a tool for benchmarking different backends. So let's say you're trying to determine like which backend will work best for you, like Databricks or Snowflake. So you can write all the queries, like maybe 100 of them. And then you can use Ibis to just like run the queries on different backends and determine which one is like the cheapest or the fastest for you. So here's an example of somebody who just discovered Ibis for benchmark, and he can just like Weibo chooses like run all of his codes, or maybe all of their code and knows the gender. Sorry. Yeah, we have also done a few of the experiments, like just benchmarking a billion of rows. So Ibis is a weird project. So we has published 10 things I hate about pandas in like 2013, and then he started Ibis at the same time he started Apache Arrow because he is the person who's driving this composable data system. I forgot the name. It's just like vision. Yes, the word vision. But then like he kind of like focused on Apache Arrow first, and we picked it up in around 2020 or 2022, and ever since you can see like there have been a lot of like rapid adoptions of like Ibis. And I think it's a link to Ibis. It's on GitHub, so you can check it out. And if you want to get in touch, I'm on LinkedIn and Twitter, and I'm also here. So like, please feel free to reach out. Thank you so much.